So first of all, thank you everyone who's decided to come back, maybe for the second or even the third time to this Model AI webinar. And I see we have some repeat people here, but just for the people who might be here for the first time, I just wanted to reiterate that the reason that we're hosting these webinars was that, of course, all the events that we were hoping to attend in the game industry over the course of the year were canceled. And in response to that, well, we decided at Model AI that we would do our best to organize something for the community that would also allow us to talk about the things that we care a lot about, which of course is AI and machine learning for video games. So today, the topic of the webinar is going to be defeating bots with machine learning. And we're following very much the same format that we've been having the other weeks. Today you have myself. My name is Christopher Holmgaard. I am a co-founder of Model AI and the CEO. And I have a background as a game developer in Die Gute Fabrik. I also have a background as a researcher in AI and machine learning for games. And way back when, I used to work in psychology and psychometrics and those kinds of things. And I'm joined today by Chris Carvelli from our team. And I don't know, Chris, if you want to say hello and just introduce.
Sure. Hello, everybody. I'm Chris. I just recently graduated in my master as game technology, and I do basically the game design, game technology, and I recently started Model AI as a game developer and AI researcher, where I do mostly game engine integration with our tools, and I am the lead developer on the bot detection tool, Model Assure.
Yeah, thanks so much, Chris. Yeah, and as Chris said, he's the person on our team who does a lot of our work on our engine integration plugins. So if you were here for our talks on game playing bots and game architecture, a lot of the work that you've been seeing there has been Chris's. He also works on bots from machine learning, and he's our resident expert on bot detection because he's our lead developer on Model Assure. And before we sort of like jump into the topic of today, I should just say a little bit about Model AI. For those of you that have been here before, this is the part of the webinar where I give the advertisement, like on a podcast. So apologies, but no. The background for Model AI is that we're a company with a mission to make AI and machine learning available and as easy to use for as many game developers as possible. And we offer 4 products that are based on basically sort of like one integrated data collection process. The first one is Model Experience, which is all about making sense of player engagement from telemetry, making sense of your players. The other one is Model Play, which is based on making bots based off human data that you can use in your game development process or even once you launch your game. We also do machine learning driven content generation, and sometimes you can use the data that you collect for experience modeling or for the bots. You can use that to evaluate some of that content. And the fourth thing that we do is we have toolkits and processes for machine learning driven cheat detection. We call that Model Assure, and that's what we'll be talking about today. So the format is the same as the previous weeks. First, I'll talk a little bit about like why is cheat detection relevant. That probably doesn't come as a surprise to anyone here, but I'll just motivate it with a few stats, and we can talk a little bit about why that's important. Then I'll talk about different approaches to cheat detection. There are many different ways of approaching the problem of cheat detection and prevention, and we're just talking about one of them today. And I'll talk a little bit from the psychological perspective about how you can leverage human behavior in that process. And then finally, I'll hand it over to Chris, who will be doing a deep dive on some of the methods that we use for supervised and unsupervised learning for detecting anomalous behavior in games. As always, if you have any questions, feel free to shoot away in the QA section. We can also do questions at the end of the webinar. We'll try to answer as many as we can. And with those words, I think we should just get going. So the first question that you might ask is, why do you need to have cheat and bot detection for your game? Why is this potentially a problem for anyone developing a game? And apart from the obvious fact that it might be that might seem unfair if you have cheaters in your game, it's actually can have a massive impact on the player experience. There's a great report on this by Erdato, which surveyed more than 10,000 people, of which more than around 6,000 were gamers, which is freely available online, which I think is worth looking into. And in this survey, which was based on subjective reporting, around 60% of the people who play games online reported that they feel negatively impacted by cheating when they play online games. So that means that this is like a widespread problem for online multiplayer games. Another fact that, or another finding that they found in this report was that players generally report that they feel more likely to stop playing online multiplayer games. 77% of the respondents said this. And people not only do people feel do people feel more likely to stop playing, they're also less likely to invest in the game by spending money on, for instance, in-game purchases, which is something that 48% of the respondents said. And in spite of this negatively impacting the experience for so many players, they also found that around 12% of the self-described computer game players in this report said that they frequently used third-party tools for cheating in online games. So this is actually quite common, and it's a phenomenon that has a strong impact on the bottom line of game developers, both in terms of retaining people. It's something that drives churn, and it's something that pushes down in-game purchases, which eventually, ultimately makes game development less sustainable, of course, and less profitable. So, of course, this is a concern to game developers around the world. And ultimately, when you look at this, there's sort of like a larger perspective where you can consider like this kind of cheating is really also a process that in a larger perspective erodes the trust in the game and the player community around the game. So in many ways, you can consider the use of cheating tools, cheating, and the use of bots as basically another kind of toxic player behavior in your game, which of course is something to be avoided in order to ensure the best experience for everyone. Another fact that you might find if you do a simple Google search is that it's not hard at all to find vendors of different kinds of cheat software. We didn't want to link directly to any particular place or site in this webinar, but I think if you're interested in sort of like surveying what's out there, you won't even need to go to the dark net. You can simply go for a Google search, and you'll find plenty of vendors who will offer different kinds of tools and cheats of various kinds that you can use, that they're offering people to use for cheating in games. And typical features that you'll find out there are tools for enabling things like extrasensory perception, so basically letting you see where the enemies are, looking through walls, having radars that tell you where other players are on a map, gaining player information that you're not supposed to have. You'll find various items out there for aiming and automation software that will automatically shoot or aim for you as you're playing first-person shooter games, other kinds of sort of performance-enhancing software. And you'll also find various kinds of like local game modification tools that might help you cheat or play better by removing, for instance, recoil or other kinds of sort of like visual distractors that the game designers built into the game as part of the balancing of the game and part of the intended experience. So very easy to find out here, and there's a whole shadow economy of sort of delivering these kind of tools to game players who want to cheat. Those like 12% of the player base or more that are interested in engaging in those kinds of actions. So I just want to check before I move on that audio is good again. Do we have audio, Chris? We're fine? Okay, great. Cool. So in terms of different ways of addressing this problem, there are sort of like a plethora of different approaches that game developers are taking. And we don't aim to cover all of them today in this talk, and we're certainly not experts in all of them. We just want to talk about the one that we particularly know about, which is the machine learning and behavior-based cheat detection. But of course, there are many other methods. Sort of, a standard way of setting up cheat detections, of course, for some games you have an authoritative multiplayer server where you replicate the game rules and you make sure that input and events are verified there. You'll see people who build in software protection. Maybe you encrypt the game files until the game starts. Maybe you have different ways of fingerprinting and keeping tabs on what's happening on the player device. And of course, a big part of preventing cheating and detecting cheating is also being active in the player community and participating with the players. So there's a huge component here, which is about managing and supporting your player base. And we're not really diving into this in this webinar. Today, we're just talking about methods for detecting anomalies and maybe identifying the players who are doing things that seem suspicious. And the approach that we take to this in Model AI is all based on telemetry. If you've been to some of the other webinars, you might know that we're big proponents of collecting detailed information about player behavior in games. And apologies to those of you who've seen this slide before. But again, we think that one of the most important things, one of the most important ways that you can gather information about how your players are acting in the game and how they're experiencing the game is by collecting low-level and detailed telemetry at a level that works really well with the particular design of the game. And how do you determine the right level for implementing telemetry? Well, that will always be sort of like a design question. So this is something that you need to decide for your individual game. But we are always proponents of the idea that you should be implementing telemetry and data logging at the level where the most important decisions or the most important events are occurring in your game. And particularly for detecting cheating behavior in games, we find that a lot of information that can be relevant to that is typically found sort of like in the lower level events of the game. And one of the reasons for this is that games are, of course, fundamentally interactive systems where when you're engaging with a game as a player, you're always engaging in this loop of perceiving what is going on in the game, deciding what you want to do about it, and taking an action on that information. So fundamentally, this is sort of like how you interact with games. And interestingly, sort of like the human mind, the human brain, or the human body as such, is a system that has some fundamental time-based limits to how we can interact with interactive systems like this. So if you look at sort of like these 3 steps in interacting with a video game, well, it takes around 100 milliseconds on average for the human perceptual system to make sense and take in the information of some kind of like change of what's going on in a video game. Then it takes around 70 milliseconds for the cognitive system, at least, to make a decision on that. And of course, if it's a more complicated situation, it might take longer. And then we have to send sort of our decision about what we want to do about it, our input to the computer system. Well, we have to send that back to the motor system, back out through our muscles, so we can actually put an input back into the computing device. And these sort of like limits are relatively and surprisingly stable across different ways of interacting with the computer system. And they're also relatively stable across people, which means that we get sort of a statistical distribution that we can use to make sense of how people are interacting with our game. And if people are not following the distribution that we would expect, well, we can use that to sort of like detect anomalies and suspicious behavior. And no matter what kind of like interface or interaction system that you have, well, you'll see that with all these different kinds of interfaces for games have sort of like different properties. This kind of cycle, this loop that I was just describing happens at different frequencies. But because the games are designed to sort of like drive this behavior as interactive systems, well, what you'll naturally see is that people have typical ways of interacting with games of different genres. If we look at a mobile game, there's a certain interaction frequency and certain patterns you touch on the screen. Same thing for a first-person shooter game, where there will be typical ways of moving the mouse, typical sort of like patterns to how often you click and how you interact with the keyboard. If you're playing on a game controller, same thing, but these patterns will sort of like maybe be input through the dual stick system. Or if we're talking about a MOBA game, well, again, we'll have like certain ways of moving over the screen and interacting with the system. And we'll have a certain rhythmicity to this that we can leverage when we're interested in understanding if the behavior that we're seeing conforms to what we'd expect human behavior to look like. And that is what we're trying to leverage in our solutions for cheat detection at Model AI. But of course, there's the caveat that players are different. So it's not the fact that you can just use one model for all your players. you might have to take into consideration that if your player base is made up of different kinds of players, you may have to sort of like subdivide them and work with different parts of the data set. Just an example of this that I want to bring up today. Here you're seeing a graph from some great work by Tarkovsky et al., where they investigated people's performance in Battlefield 3 as a function of age. And as a person who resides on the right-hand side of the curve here, unfortunately, I can definitely tell you that my perceptual decision-making and motor system is slower these days than it used to be. So you might need different kinds of models for different parts of your player base. But I don't think that these kind of methods are necessarily sort of like the catch-all for addressing the problem of cheating behavior in games. But I do think that applying machine learning to this kind of like human behavior, leveraging these specific human characteristics, can give us another line of defense for cheat detection and has properties and benefits that we can't get from any of the other kinds of cheat detection that we listed earlier on one of the previous slides. And at this point, I think I'll hand over the microphone to Chris. We'll talk a little bit about how we specifically implement this in Model AI. So Chris, I'll try and make you the host here, and we'll see how that goes.
Thanks. So, as we said, here in Model AI, we follow most of those principles to actually detect games, to try to act as an additional layer after all the other classical tools have failed. We reside more or less in the gray area where defining what is a bot and what's a human, it's a bit more difficult. Because before we start, it's important to mention a couple of principles that we try to follow while doing this work that we found out while addressing these kind of problems in the wild. First of which is that it seems obvious, but we as a developer, we don't know the kind of bots that are out there. Probably know most of them, but that's not the one that we are really interested in. It's usually an arm race between the developer and the cheat detection and the cheat producers to try to outsmart each other. So we can't just try to find a pattern that identifies bots. So our approach is to try to describe as better as we can the human population, and then any outlier to this description that we find, it could be a bot. Next is that, again, it's not so obvious that this is a particular deceptive problem, because similar to like disease detection and techniques like that, here is not only important the accuracy of the system, but probably even more the number of false positives that the system gives. It's not very useful to have a tool that detects all the bots if a lot of people that are actually playing the game normally, just different like most of the other users do, are flagged as bot. It depends a bit on the use case. So, for instance, if we are an esport organization that has tournaments with big money prizes, of course, we want to be very, very careful, because there's going to be a human watching the votes and validating the bot, and having a lot of votes to watch to understand what is a bot and what not is not really useful. On the other end of the spectrum, instead, if we try to have an automated system for some casual online gaming, it's important to not report too many truthful users as bots, because that is going to degrade the trust of the community in both the game and the developers. That, as we've seen, is not a thing that is desirable. Then most of the time is also important for the system to be understandable by a human why a certain decision has been taken, like especially if there is a human in the loop that has to verify the claim of the system. it's much easier to look at a VOD of a play session, knowing where a bot could have been used, and which kind of bot it is, and which behavior of the player entered the system that could have been a bot. It would make the time spent identifying a bot much lower, and thus much cheaper. Finally, this system should be actionable. So again, it's very useful to have a model that spit out some number, but then it's important to understand easier which was the player in all the other analytics of the company. As this player used bots many other times, where it is, and all this kind. So we try to put together a suite that gives all this information available and easily digestible for whoever needs to address this topic. The two main methodologies that we used for this are supervised learning, in which simply we use neural network to identify patterns in gameplay and other kind of interaction that the user has with the game, and we try to predict what is supposed to happen in this particular situation, what most of the humans will do. And if it is too different, again, we flag a warning that it could possibly be a bot. And we're going to see afterwards how we can handle into account the fact that humans in any similar circumstance, they could react in many different ways. The other approach is either statistical analysis, or we are investigating supervised learning methodologies to do this. And is more or less similar, but instead of trying to predict the next action that the user is supposed to take in a particular situation, we take into account every action taken as a whole, and we perform some analysis to understand statistical distributions in the underlying data and see where those patterns are broken and how they are broken. There are several aspects of the game that we take into account while doing this decision, and they are mostly rely on the gameplay data collected by our telemetry, by strategic and tactical operations, by the action that the human or the bot took, and also with the hardware telemetry that is collected from the device running it. Because we are under the assumption that cheat detection, the cheat tools, they use a lot of resources and in very specific patterns that are easily recognizable. For reaction times and our telemetry, we use statistical analysis, and in particular a form of clustering that we call the binary cluster, in which we don't try to identify structure in the data, but we just try to use clusters to describe the data as much as we can. So here, as we can see in an example, sometimes there are some bots that are very easily recognizable in separate clusters, but most of the bots, or at least the one that we are most interested in recognize, are very well hidden in the middle of normal human behavior. So what we actually do is we try to dive much deeper in the data, and we figure out that locally at a certain point, every bot is actually an outlier in a specific subset of the population. So what we do, we get all those clusters, and we don't just try to find what's the closest cluster to the data. We check the distance to all the clusters. We try to identify which cluster they should appear and how they are distant from this particular cluster. So as we can see, in this particular case, the bots were supposed to belong to the red cluster, but they are way too distant and they are flagged as bot, even if they are very, very closer to a different cluster. The next one is about the input shapes. So the user interaction with the hardware. mostly, and the game input. Again, similar as Christopher said before, humans have this very specific patterns that are mostly similar but slightly different, and usually the bots are either very, very regular, too much to be humans, or way too random because they try to fool this particular system. But they are they have like noise in their input that has different distribution from the human side of it. And again, since this is mostly specific on the game, not only the genre, but sometimes of the very specific game of its input patterns, we can leverage all the telemetry information that we have about the game to describe this particular population using data that no attacker actually has. Finally, the last one on the tactical and strategic level, we try to predict from a game state or a sequence of a game state, a sequence of action that are likely to be taken in that particular situation. And we try to identify outlier in this distribution that are possibly bot. There is a recent addition that we are experimenting with that we call the zoo. And it's basically the observation that it's not very useful for us to try to recognize existing bots because that's not our main focus, but it could be a very useful additional layer of detection after there is a very, very successful toolkit out there. We take our approach on his head, and we instead try to describe as well as we can a population made of only that particular bot. And so before actually screening it with the main system, we send a session through this additional layer that is able sometimes to find a bot even without the need of more complex solutions. I already mentioned most of these, but just to iterate on the point, those machine learning approaches have some very specific advantages. The first is that they learn from the players and so leverage the specific distribution on your own game that is much more difficult to do with other tools, either because if they are off the shelf, they are off the shelf for everybody, or if you implement yourself, it's difficult to integrate data from your player population inside those tools. And even if the player population changes with time, and using machine learning and keep training those models, we are able to update with them and keep up with the progression of the game, with the progression of the meta. And finally, as we said, we are able to use information that cheat producers don't have, so it's much more difficult to fake and fool. Finally, before concluding, a couple of practical tips that we found while we were working on some real-world scenarios that we would like to share with you. The first of all is that contrary to what is usually said to machine learning, there is this concept of overfitting. Well, you don't want your model to be too precise on the data that you have at hand, because then it will probably be very bad at generalizing and deal with new data. But in our particular case, we found out that having a bot specialized on a very specific segment of our population makes for a much more robust system. The segment could be divided by date, by player skill, by the device type. And every model, it would be very, very good at working with player in that particular segment and very bad in everything else. But if we have a library of all those models that are selected appropriately for every session, they become much, much better. On the other hand, a general model that works on the entire population is much better to work in more casual scenarios, because is require much less maintenance, and it doesn't need to be as precise. Like, for instance, if we are working with esport and money, it just has to be good enough to work as deterrent for people actually using bots. And since also the kind of penalties that the player will incur if they are recognized as using bots are less important, we can get on with lower precisions and lower and higher false positive ratios. Then again, even if we want to use specialized models, it's also important to realize that maybe we're not interested in recognize bots for all our population. Maybe we want to use it for tournaments, so we want a model that is very good on the top 100% of the population and on the top 100% of our players, and everybody else we can just ignore. We end up having only one model that is very good in this specialized area, and not that much else, but it solves very well our problem. And finally, if we keep all the models in a library and we keep testing and updating them using cross-reference compilations, we are able to automatically select very good models at any given time, boosting by quite a lot the overall precision of the entire system. And finally, this is something that we are still working on. It's very important to keep the data that we use to train our model as clean as we can. Of course, when the data that we are going to use to train our model at the beginning are going to be from QA sessions that we pair with bots that we know and probably created ourselves. So we are going to make models that are not very good at generalize with different kind of bots, but at least are trained on clean data. The more the game goes on, we are going to integrate those data with real data from the wild, and it's quite possible that real bots are going to be misclassified as humans and are going to train future models as humans, and it's going to lower the overall precision of the system. One tip that we have in this case is that it's useful to keep classify all the data with new models, because most of the time updated models are able to find all the cheats that previously we were unable to detect, and this loop makes the model slightly better in the long run, but it's still an open question for us. And that's it for me. If Christopher, you want to take over from here?
Yes, absolutely. Here we go. Sorry, I was just trying to answer a few questions in the meantime. I'll just transition back to the screen. There were a few questions about references and recommendations, and we included a few here, and we're also happy to take email questions about specific cases, and we can comment on that as well. But I'll just leave this on the screen for just a second in case you want to grab a screenshot. There's the Global Gaming Survey. For those of you who are really interested in psychophysics and sort of like human performance, I recommend this paper on using first-person shooters for basically showing that everything that we know from psychophysics tends to transfer into many video game situations. Steve Swink's Game Feel, the paper around aging and Battlefield, and then there's a real classic here, Engineering Psychology and Human Performance. Lots to learn also for people who are interested in esports, I would reckon. I'd also highlight these 3 different talks that you can find on the GDC Vault if you have access. There's a great talk from Uken Games about dealing with cheating. From Bohemia Interactive, different approaches for catching people who are cheating. And then from 2018, there's a really great talk by John McDowell from Valve describing how they use low-level telemetry and deep learning to deal with cheating in Counter-Strike Global Offensive. In their case, they also use information from their community and from the judges that they have in their Overwatch system, So it's a little different from what we described here today, because in our case, we don't necessarily assume you have that kind of information, but really, really great talk as well. So with that, I'll just say thank you for your time, and let's step into dealing with some of the questions that we were getting on the QA. Before we go there, just want to say that we also have a couple of extra webinars planned out. We don't know the dates yet because we do spend a bit of time preparing it. So we'll just go back to focus on a few other things, and hopefully we can come back in not so long announcing the next dates. But we want to talk about player experience modeling as well soon. We want to be talking about procedural content generation, and eventually we'd like to offer some tutorials for people who are interested in how to integrate model experience and model play into their games. Also, you're very welcome to always write us and reach out to us on Twitter. And we're also planning to start a Discord for the community. So as we follow up with the recordings of these webinars, we'll be sending out information about how to join that as well. But I'll just stop my screen share and we can step into the QA section in earnest. So one, can you name a few games on the market that use machine learning in cheat detection and how? And again, this is not necessarily a topic where you get the where it's not the easiest topic to gain information on, sort of like in the public space, public domain. But I'd highlight the CSGO talk by John McDonald from GDC 2018. Really, really good example of how you can do it. And for recommendations, yeah, definitely the few resources that I presented here today. And if you want to shoot over an email, or once we get the Discord up and running, we can also have a deeper conversation of some of the stuff over there. And then we had a question about whether these models that we were seeing here were general or not. So basically the question was, is this something that I can just plug and play into any game, it'll just work? And unfortunately not. In this case, what we're presenting here is dependent on telemetry data from the individual game. So the way that we build the models and train them is general, but you need data from each individual game in order to get started. And I don't know if you want to follow up on that, Chris, or no, that more or less covers it. Yeah. Okay. So those were all the questions that we had outstanding in the QA section. So unless anyone has any further questions or anything comes to mind, then I will just say, yeah, thank you too. Thanks for joining. And thank you for the good questions. I'll just say thank you for your time. Thank you for your interest. We will be posting the videos from the first 3 webinars online as soon as we're done editing them. We're getting a little extra spruce and polish before we put them on the internet. And then as we send that out, we'll also be announcing our Discord that we hope could be a future home for these kinds of discussions and this kind of communication. So thank you very much, and have a great day, afternoon, evening, depending on where you are. Thank you.